You know you love this course. You think about the Lego videos you like to watch of those gear mechanisms with those complex designs, making all those movements, creating. Think about that engine you saw. You literally saw someone make a piston engine out of Lego parts. You can learn how those mechanisms move. This course is that. Now, think about that. Keep that in mind. Also, keep in mind, you want to get married to Blanca. You love her, and you can't wait to start a family. Keep that in mind when you study, so that you can work hard, you can finish your degree, get out of school, and finally move on to that next step with her. Now, this is chapter 4, instant centers. As we study this, keep that all what I just told you in mind. This chapter is on these types of drawings. It's just step 1 for these kinds of problems. There's later chapters you'll see the following steps. Step 1 is always to locate the instant center of a mechanism, or all the instant centers, as is shown here. This is just an example image. This is the type of question you have. You're going to have to do this. This is simple. An instant center is a point in a body around which another body rotates. That's one definition. The other part would be a point to two bodies with the same linear velocity. Okay, this is gibberish. You don't understand that. Now just think. Look at the visually identifiable types of instant centers. That's the first thing you want to think about. Each one of these points where the bars meet, these are instant centers. It's where bar 5, as identified here, rotates around the pin, which is attached to bar 1, which is just the ground. You know this. So bar 5 has as its center, if you want, of rotation, the pin connection. That makes sense. Same thing here, bar 4 and pin 1, bar 2 and 1, and then between bar 2 and 3, they have another pin. They rotate around there. This image is simple. There's only pin connections. We're going to look at other versions. There's also other simple identifiable instant centers. These include the sliding body ones. So when you see a body, one of the links or members, you can call it, but it's a body, a square box is how it's represented usually. And it just has a sliding motion on usually the ground. It could be on another member, usually the ground. And the other member, or the ground, is not moving. This is just sliding against it. You find the instant center. It's easy. It's a vertical line that's perpendicular, not vertical. If it's slanted, it's slanted. But it's a line that's perpendicular to the surface which is being slid on. So in the example of the ground, it would be perpendicular to the ground. And so it would cross, the ground at a perpendicular angle, and it moves along with the object as it slides along the ground. Technically, what it's signifying is that the instant center is at infinity. You never reach infinity, so you can only represent it as a perpendicular line. Now, there's other easy identifiable ones, such as on a rolling body. So we've already looked at the pin connection. These are the simplest ones. Sliding bodies, that's the next simplest one. It's a perpendicular line to the surface being slid on. Now, the rolling body. What's the instance center for the rolling body? It's easy. If there is no slip, then it's just the point of contact where one body is rolling on top of the other. Where is the instance center? At the point of contact, always. Okay? Keep that in mind. So those are the first three easy ones. Direct contact mechanism. In these situations, you're looking at instance centers on where two bodies are moving. So it's not like earlier sliding and rolling. It's a little confusing with the name because it's sliding contact and sliding body. There's only one member of the two in contact that is sliding. And here, only one member of the two is rolling. In direct contact mechanisms, you see both parts are rolling / sliding, not only one on the surface of another. So let's just quickly say the rolling contact, you know it. It's found at the point of contact. It's found at the point of contact. This is simple. The sliding contact, this one's the one you're going to have to think about just a little bit more. When the two bodies are moving, and so they're sliding against each other, there is not, the instance center can be found as a point which lies on the normal line. So what's the normal line? The normal line is a line which is perpendicular to the surfaces of both bodies at the point of contact. So when the two bodies, they may have a curved surface, but at their point of contact, they're technically parallel. Think about them as parallel, so you can put a line perpendicular to both. There you go. So you know now that the instance center is somewhere on that line. How do you find the exact location? You want to use what is the Kennedy theorem, which is explained later on, but essentially it states that between three members, all three instance centers are aligned. They're all on the same line. So now we just need to find a third member to involve in our formula, where in our situation. This situation, we're looking at two bodies that are in direct contact and they're sliding against each other. You find a third member, let's say the ground. If you have the instance centers for member 1 and 2 and then 1 and 3, you can find the line between those 2 points. Okay, so the location of instance center between member 1, which is the ground, and member 2, which is the first arm in the sliding contact. Then you can find the instance center, or if you also have the instance center for the ground in member 3, you draw the line where the normal line, remember the normal line is perpendicular to the point of contact. The normal line, where it intersects this new line that we drew between the two other instance centers, that's where your actual instance center between those two sliding contact points or members is. Okay, so it's a little more complex, but it's not nearly as hard as it may sound. We're going to look at one in a bit. Now, so that's all of the easily identifiable instance centers. There's more. There are more instance centers, usually. I'm pretty sure always, in fact. You're never going to have only, first of all, in your exams, you're never going to have. I don't know if on simpler problems, you can never have an instance center. I suppose I'll have to look into it. Remember this question if you want to marry Blanca. Keep this in mind. Be diligent. Look it up. Anyway, to find the number of instance centers in a body, you do this simple formula. N is the number of instance centers, and small n is the number of bodies. Okay? So here we have the bodies. 1, we have the numbered. 2, 3, 4, and 5. So there you would have a small n as 5. You do this little simple formula and you find the number. So 5 times 4 is 20. And then you divide that by 2, you get 10. So there, in a situation with 5 links, you have 10 instance centers. In a situation with 4 links, you would have 6. So now we already went over the Kennedy theorem, which is identifying that the instance centers between 3 bodies all lie on the same line. Now, with this knowledge of this Kennedy theorem, we're going to basically do direct contact mechanisms, sliding contact style finding for all the other. A little differently, you're not going to use a normal. This time you're going to use those lines between 2 instance centers. So here's what you're going to do. You're going to start with the circle diagram. A circle, you draw it. Then, after you have your circle drawn, you're going to mark around the rim of the circle numbers, identifying all the numbers of links. So in 5 links, you would have 5 points. You are going to, since you've already found all of your easily visually identifiable instance centers, all of these ones, remember pin, sliding, rolling, direct contact, these ones, you're going to mark them as a line. So if you have a pin connection, it's between 2 links, right? It has to be. So if it's between link 2 and 3, you're going to put a line between number 2 and 3 on your circle. You're going to do that. Draw lines from the numbers to another number for each of the easily identifiable instance centers. That you've identified all of these more easily identifiable instance centers, the clear ones, you have to find the harder ones. The harder ones are the ones between links that do not have contact. They don't meet, and so they can be a little more complex to find. The trick is to apply the Kennedy theorem. When you use that, how would you implement it? You use this circle that you have, and the trick is to follow a path between 2 points. So let's say when we look at this example, you realize that link 1, which is the ground, does not have any points of contact with link 3. Now, how are you going to find the instance center? You have to find a path on the circle. Will be more clear when we do the example. You'll see how to follow the path, but you'll have to follow a path around the circle between 2 points that have contact with link 3. So let's say you see 3 link 2 contact with link 3 and link 4 contact with link 3. So these are good options for finding the instance center between 3 and 1. Why are those two good? Because they have a contact with link 1. So you have to take how it appears on the circle diagram is you'll try to find between point 1 and 3. You want to find a path that follows the line on your circle where you can only pass through 2 lines to reach the 2 numbers you are looking for. And so you need 2 paths for that. So here you would have a line between point 1 and 2 on your circle, and it would represent this point. And then you would find the line that goes from point 2 to 3 on the circle, and that would be 2 lines. You do the same for 4 and 1, and then 4 and 3, and so that signifies that those are the instance centers you're going to want to use to find the instance center between 3 and 1. How are you going to find it? Well, the process is you take the instance center 1, 2, and draw a line, a long line, through instance center 1, 2, and 2, 3. And you do the same for a long line between instance center 1, 4, and 4, 3. And once you have those two lines, they'll be along this bar, a bar 4, and along bar 2. There's going to be a point where they cross, intersect, and it's going to appear up here somewhere. That is where your instance center 3, 1 is. And so the intersection of that is the instance center. Why is this the Kennedy theorem? It's because Kennedy theorem says that any three instance centers are going to lie on a line between 3 links. So that's why it has to be on the same line as these 3, because these 3 links are going to have instance centers, and it's also going to have to lie on this line, because those 3 are instance centers of 3 separate links. And so that's how the Kennedy theorem operates. Now let's move on to the problems, because we've gone over all of the notes, all of how to find these, what are the instance centers, and now the best way to proceed is to go through an example to show exactly how to apply all of these concepts and ideas and successfully complete a problem asking for an instance centers. This is your goals. Remember these. You want to get married. Keep that in mind. It's not far away. Soon enough, if you work hard, 2 more hard years of schooling with diligent effort, you'll be with your degree, you'll be done, and you'll be able to start working in the field, doing the work you want to do, and being able to marry Blanca. Keep this in mind. You're not far away. You just need to be diligent. Keep at it. You know you can do it. Keep at it. So, now let's see how we apply the concepts we saw in the lectures, and do it in a problem. In this problem, we're going to start by finding the number of instance centers. So we're going to use this formula. And so we know that there are 4 links, because we have link 1, the ground. We have link 2 is this block B. Link 3 is block C. And link 4 is block C. And link 3 is this triangle shape D. So now you have the number of components, 4. And so you just put them in. N is 4. So 4 times 4 minus 1. And divided by 2. This is always the formula you're going to use. Sometimes you're going to have 6 links. Sometimes you're going to have 8 links. Here there's 4 links. This is a simpler problem with fewer components. And so now that we have identified the number of instance centers, we can just write them out. Just do this, write them out so that it's clear you know what you're looking for. Once you have them written out, you know which ones you're looking for, which ones you found. You can it makes it simpler, and you can have this little triangular diagram of all the instance centers you're looking for. All clear, nothing is uncertain. Keep in mind to do this, because you might omit, if you just try and be fast and rash, you might omit some. So just be as clear as possible. The next step is to find the easily identifiable ones. So what are the easily identifiable ones on this example? So our easily identifiable instance centers are the pin connections, the sliding bodies, rolling bodies, and then the direct contact options of sliding and rolling bodies. Remember, direct contact, that's with two parts that are moving against each other, whereas sliding is one part is fixed and one part is moving. So what do we have here? Well, when we look here, we have the lines. It's a little unsure, but it's a little hidden. But we see that there's a pin connection between 4 and 3. So let's just circle it and mark it. Same thing down between 2 and 3. It's another pin connection, right? And then block B and block C are both actually sliding bodies. They're sliding against link 1, the ground. So remember, for sliding bodies, it's just a line that's perpendicular to the surface being slid on. So it's here it's going to be perpendicular to this. So here, as in for the situation of 4-1, it's going to be perpendicular to link 1, to the ground, going through the pin connection. And then here is going to be perpendicular to link 1, but again, since link 1 has an angle, these lines are no longer, they're not parallel, but that doesn't matter. They don't relate between these two. They just relate to the block that's sliding and the surface. And so the angle of the surface is what you're looking at. So once we found those two pin connections and those two sliding bodies, you've now found 4 of your 6 instance centers. Now we are looking to find the last 2. And so for the last 2 missing ones, which are 1, 3, and 2, 4, you're going to have to use the circle diagram that we've been speaking about, and you're going to have to use the Kennedy theorem. So let's see. So now we have the circle diagram. This is how it appears. The circle diagram is just draw a circle, put points around it, numbering the links. So there's 4 links, so you put point 1, 2, point 3, and point 4. And now, which instance centers have we already found? The easily identifiable ones. We've found 1 and 4, which is this line. So you can put a line. You see the black filled out line. Then we found 3, 4. So 3, 4 is here. We found 1, 3. Not 1, 3, sorry. 2, 3, and 1, 2. These are the lines, the little circles identifying the pin connections. Those are the ones that we have identified. And so the missing ones are 1, 3, and 2, 4. And so I've drawn them in with this purple dashed line. Those are the ones that you're now looking to find. We talked about following a path where you only require 2 lines to follow the path between the 2 missing points, instance centers. So here, let's look first for a connection between 1 and 3. So when you want to find an instance center between 1 and 3, you can follow the path 1 to 2 and 2 to 3. Those are 2 lines, okay? You follow them, and there you are. You've reached from 1 to 3 through 2 lines. Now let's find a second path. You can go from 1 to 4 and 4 to 3. There you go. You have your second path. The trick now is you want on your image, on your drawing, to make a line, to draw a long line that goes through both instance centers of those 2 lines. So when you draw a line through the instance center 1 and 2, and the line also goes through instance center 2 and 3, 1 and 2 is a vertical line, and then it already goes through 2 and 3. So this vertical line is the line we're looking for to draw. Since we're using a sliding body, there's already a vertical line, we can just work with that one. This is just for construction, is to help. It's not identifying anything more than it's just to help you find the next instance center. It's not representing anything. So you have to remember this green one is representing the instance centered 1, 2. The new line that you would be drawing would be representing just the line on which somewhere along that line instance center 1, 3 is found. Now you're going to do the same thing with paths 1 and 4 and 4 and 3. So since we're in the same situation in both ways, you're going to also have another line going through line 1, 4. And so it's the same line, we don't need to draw it. And what we're next looking for is instance center 1, 3. And 1, 3 has to lie on a line with, on the same line as instance center 1, 4 and 3, 4. And then on a separate line, it also has to follow, it has to be aligned with instance center 1, 2 and 2 and 3. And where will that happen? Now, let's move to see where that actually happens. It happens right there, right? When you extend line 1, 4 with this purple extension, you see that it intersects there, up in this corner. That is your instance center 1, 3. So when you look for 1 to 3, you have to go through those two lines 1, 2, 2, 3, and lines 1, 4, 4, 3. And where the extension line crosses is instance center 1, 3. You're going to do the same process to find instance centers 2 and 4. So now when you want to find 2 and 4, what are you going to follow? What path are you going to be able to follow? Well, let's look. You have one option which has you go through instance centers 4 and 3, and 3 and 2, okay? So 4 and 3, and 3 and 2. Yes, 4 and 3, and 3 and 2 gets you from 4 to 2. And the other one is 4 and 1, and 1 and 2. So that gets you to from link 4 to link 2. This is a little more complex now, because when you look at it, you can easily draw a line that goes through instance centers 2, 3, and 3, 4, 2, 2, 3, and 3, 4. This one, you can draw a line just there between those 2 points. And so you know now that the instance center lies somewhere along that line, right? Because we said it lies on a line with 2 other instance centers, so that's the line it's going to lie. So where exactly on that line? Now we have to draw the other line between instance center 4, 1 and 1 and 2. And it'll lie on that line too, or line as well. The thing is, this time we're working with 2 sliding bodies. So for 2 sliding bodies, how are you going to draw a line if the instance center is at infinity? How do you draw a line at infinity of C, infinity 1, 4 and infinity 1, 2? It doesn't happen. You can't do that. What is that suggesting? Are you giving up? No. Because you want to marry Blanca, you are not giving up. You're going to have to remember that when you're working in a situation with two infinity instance centers, when you're working with two infinity instance centers, then that means that the first line you originally drew was actually a 2 infinity instance center as well. Okay? So you can draw the line from 2, 3 to 3, 4. You draw that line, and then you just mark IC instance center 2, 4 to infinity. And that's what we have done here, right? We drew the line. We've identified that instance center. We cannot draw a line between the 2 infinities, the IC 1, 4 to infinity and IC 1, 2 to infinity. You can't draw a line. So that means that the infinite center 2, 4 is also to infinity. And it's just the one line you drew between those other two. And now in this problem, you have found all of your instant centers. And now the problem is resolved.